So in the last class, we started with the one component system. Two of the one component systems, that was the water and the carbon dioxide, we have seen in the last class. The one component system, one more we have to see, that is in our syllabus, is about the sulfur. So now sulfur, it can exist like the carbon dioxide and water, they were existing three of the different forms, like was the solid, liquid and the gaseous forms. But the sulfur, it exists in the four of the forms. So sulfur, it exists in four of the forms. Sulfur exists in four forms. What these four forms are? Four forms. One is the sulfur rhombic. Sulfur rhombic. Rhombic. Other is the sulfur monoclinic. These are the two forms of the sulfur only. Sulfur monoclinic. And the other is in the liquid phase, sulfur in the liquid, sulfur liquid, and the lastly in the vapor phase, that is our sulfur vapor. Sulfur vapor. Like, so sulfur rhombic, we are going to denote it with S with a subscript R in its subscript. R is there in the bottom, and here also it is SM. This is SL, and in the vapor phase we are going to draw it like S in the with the subscript V, right? So let us see that like three of the phases, they were easily able to exist in the easily able to coexist in equilibrium with the one another. Is it possible that four of the phases can existing in the equilibrium with the one another? So here, if let us check that if four of the phases can exist in equilibrium with the one another, that is if sulfur rhombic, monoclinic, sulfur liquid and the vapor, if all of these can exist in the equilibrium. So degrees of freedom, if we have to calculate for this, F is equal to C minus of P plus 2. This is the rule that we already know. So here we are talking about the one component system. So C value, it is going to be equal to 1. We are checking it for that four of the phases, if they are in equilibrium or not. So phases is going to be equal to 4. So this is going to be 1 minus of 4 plus of 2. So we are getting here is 3 minus of 4, that is equal to the negative. That means it is denoting that negative of the state variables or the degrees of freedom or the variance it is denoting. So in the negative, this variance it cannot exist. That means four of these variables, they are not able to exist in equilibrium with the one another. So the maximum how many phases can be there in equilibrium with the one another is 3 only. That is like in the previous cases also we have seen. So here also the maximum 3 phases that they are able to exist in equilibrium with each other. So it is negative, hence, so let us just write it on the another. Since degree of freedom it is coming negative, since F is negative, that is not possible. That is not possible. So four of the phases cannot exist in equilibrium with the one another, right? With the one another. So maximum how many phases can exist in equilibrium is 3. So maximum number of phases that can exist in equilibrium is equal to 3 only, right? So the phase diagram for the sulfur is going to look like this. That is the pressure temperature curve we are drawing. So for this we have four of the phases: sulfur rhombic, monoclinic, liquid and the vapor phase. All of these they have been shown. The maximum how many are there in equilibrium, that is 3. So here we are having 3 of the points B, C and E, where we are seeing that 3 of the phases are in equilibrium with one another. So far what we have seen in the water and the carbon dioxide, that phase diagram, we are to focus is upon the different areas, curves and the triple points that are existing over here. So here we are seeing that different areas that are present are, so areas we are having over here is, so the area is A, B, C, D. One of the area is this one, that is denoting our sulfur vapor phase. So A, B, C, D, that is denoting our sulfur vapor phase. Next we can see here is FECD curve, that is denoting our liquid phase. So our FECD area, that is denoting our sulfur liquid. Area EBC, you can see that is denoting our monoclinic. So we have is ECB or EBC, that is denoting our sulfur monoclinic, and ABEF, this is the last curve, that the area we can see here is, that is denoting our sulfur rhombic, right? So the number of degrees of freedom in this in the areas, that is going to be, so F, that is equal to C minus of P plus of 2. So component we are having is 1. So all these areas we are seeing that the number of phases that are existing is equal to the 1 only, that is either the sulfur vapor, sulfur liquid, monoclinic or the rhombic. Only one phase is existing in that. So we are seeing over here is number of degrees of freedom in the areas, it is equal to 2 only. So number of degrees of freedom is equal to 2 in the case of the areas. So what we have to remember in this is that suppose if some point is given to us in this areas, so suppose here a point is mentioned, suppose let us label it as X point. So they are asking you that that how many degrees of freedom are required to describe this or the variance of this. We are going to say it is a bivariant point, or it is a 2 of the degrees of freedom or the variances are required in at this particular point, right? That means we must know the condition of the pressure and the temperature to study about this particular point, that is our X, right? So the next thing is about the curves that are present. So the curves here we are having is our AB curve. So we are having here is AB curve, that is a curve representing an equilibrium between the rhombic and the sulfur vapor. So in the AB, along the AB curve, we have the rhombic is in equilibrium with our vapor phase, right? The next curve we are seeing here is a BC curve. So our BC curve, that is representing an equilibrium between the monoclinic and the vapor phase. So here it is, monoclinic is in equilibrium with the vapor phase, right? So the next curve we have is CD, that is representing an equilibrium between the liquid and the vapor phase. So the CD along this sulfur vapor is in equilibrium with the sulfur liquid. Next curve we are seeing over here is this EF curve,